Hello again, everyone. My name is Michael Wolf with Pi3G, and we're here for the second installation in our series of trusted platform modules. In today's video, we're going to be doing file operations, namely a proof of concept of all the commands that you need in order to do an encryption and decryption of a test file. The algorithm that we're going to be using is called RSA, specifically the 2K variant. One of the good things to know about this encryption algorithm is that it is asymmetric, which means unlike some encryption algorithms where you use the same key to encrypt and decrypt a given file, RSA has two different keys. This is important because if you look back at the symmetric algorithm that has one key to encrypt and decrypt, if I want to, say, encrypt a file and send it to my friend who decrypts it, between the two of us, I need to get some sort of secure channel of sorts, because anyone that has access to that key can have access to my secure data. In contrast, an asymmetric algorithm has two keys, a public and a private one. One key can only encrypt data, and the other one can only decrypt data. The public key, or the one that encrypts, you can give to anyone you want to on the net without compromising your data. The private key you secure locally, and so long as nobody gains access to it, your data is secure. For today's video, we're going to be using RSA 248, which means essentially that it creates a very large key. In the context of encryption keys, typically longer is better. Pause here if you want to take a look at all the commands that we're going to execute. Otherwise, keep going and I'm going to handle them one by one. Both the public and the private key will be exportable from the TPM, which should raise some alarm bells. TPMs are typically about keeping things safe by keeping them resident exclusively within the silicon. This is essentially the purpose of this first command. We are essentially creating a primary root key that when we do export the public and private key, specifically the private one, gets encrypted using the main root key. So anyone that would get unlawful or unwanted access to it couldn't use it without the TPM. We can now go ahead and create our public and private pairs that we're going to use for the rest of this proof of concept. We take those keys that have hopefully been generated by the previous command and load them into the null hierarchy. The null hierarchy you can think of as just a scratch pad for the TPM to do work in. We then create a test payload with this enigmatic command that no programmer understands. So we're in a good place, halfway through. We've created our keys and we've created the payload, and we can now use one to encrypt the other. So now on to decrypting. This command, unlike the previous load command, you can see it takes both the public and the private key and loads those into the TPM parent context. With the context loaded, we can now take our cipher data and decrypt it, revealing the original contents. For this and more examples, feel free to take a look at the Infineon user manual. Thanks again, and if you want to review the commands step by step, please take a look in the description. As always, if you have a Raspberry Pi project and you need integration or CRA specialists, please look us up at pi3g.com.